Performance curves. In this video, we will discuss about the performance curve. Let us see the graph as shown in the performance curve of engine speed. Engine performance curves are mainly used to study and analyze the performance of the engine at different load conditions. In such curves, the variations of different engine output parameters such as torque, indicator power, brake power, efficiency, specific fuel consumption with engine speed or load are provided. Friction power is the difference between indicated power and brake power. As friction power becomes a larger proportion of indicated power with increase in speed, brake power curve drops more rapidly as compared to indicated power curve. Mean effective pressure. In this video, we will discuss about the indicated mean effective pressure. Let us see the graph as shown in the indicated mean effective pressure in piston movement. This is a hypothetical pressure which, if acting on the engine piston during one stroke, would produce the total work of the cycle. Depending upon the indicated work of the brake work, it may be indicated mean effective pressure or brake mean effective pressure. Indicated mean effective pressure is equal to indicated power divided by LAM. IP is equal to indicated power kilowatt. L is equal to length of stroke meter. A is equal to total piston cross-section area meter square. N is equal to number of working strokes per second. RPM divided by 120 into number of cylinders of 4-stroke engine. RPM divided by 60 into number of cylinders for 2-stroke engines. RPM is equal to engine speed in revolutions per minute. BP, brake power kilowatt. Brake mean effective pressure is equal to brake power divided by LAL. Indicated power. In this video, we will discuss about the indicated power. Let us see the model of indicated power of engine. The power developed inside the engine cylinder due to combustion of fuel is defined as indicated power. Indicated power, that is IP, is equal to PM LAN divided by 60 into K, where K is equal to number of cylinders, L is equal to length of stroke, that is meter, A is equal to area of the inside cylinder, N is equal to number of working strokes per minute. Small n is equal to capital N is equal to for 2-stroke. N is equal to capital N divided by 2 is equal to for 4-stroke. PM is equal to indicated mean effective pressure, that is IMEP in Newton per meter square. Piston indicator. In this video, we will discuss about working of piston indicator, drum, reducing gear, cylinder, plug cock, spring. We will see the working principle. A cylinder C, which is connected to an engine cylinder to a plug cord. A piston D of this cylinder is attached to the top of a tension spring S with the help of a push rod. A magnifying mechanical linkage at the end of which a stylus is connected. The stylus traces a diagram on the paper wrapped around the drum. The drum is directly driven by the engine crankshaft. The movement of this spring is magnified by a link mechanism and transmitted to the stylus. The rotation of drum will be proportional to piston displacement. PV diagram is obtained on the paper wrapped around this drum. Is an average number of cycles. Indicator mean effective pressure is equal to area of indicator diagram divided by length of indicator diagram into spring scale. The first method is the one which is most commonly used. Brake power. In this video, we will discuss about the brake power. Let us see the model of brake power on engine. The brake power is the power obtained at the engine flywheel is measured with the help of dynamometers. The dynamometers actually give the engine torque, of which the BP, that is in kilowatt, can be calculated in the formula. Brake power, that is BP, is equal to 2 pi nt divided by 60,000, where n is equal to engine speed in RPM, T is equal to torque in Newton meters. Friction power. In this video, we will discuss about the frictional power. Let us see the model of frictional power on engine. Some of the indicated power developed in engine cylinder is lost in overcoming the friction at various engine parts, and remaining power is obtained as brake power at crankshaft. This type of power lost due to friction is defined as friction power. Therefore, frictional power is equal to indicated power minus brake power. FP is equal to IP minus BP. It is measured in kilowatts, that is kW. Mechanical efficiency. In this video, we will discuss about the mechanical efficiency. Let us see the concept of mechanical efficiency. It may be defined as the ratio of the power obtained at the crankshaft, that is brake power, to the indicated power. Thus, mechanical efficiency. Mechanical efficiency is equal to brake power divided by indicated power. In common, the mechanical efficiency of engines varies from 65 to 85%. Specific fuel consumption. In this video, we will discuss about specific fuel consumption. Let us see the concept of specific fuel consumption. It is seen that the specific fuel consumption, that is, fuel consumed per kilowatt hour, decreases at first and reaches some minimum value after which it again rises. Thus, the best engine speed is the one corresponding to minimum specific fuel consumption, where we get power at lowest expense. Calorific value of fuel. In this video, we are going to see about the calorific value of the fuel. Consider 1 kilogram of fuel is burned with availability of oxygen, that is air. Calorific value is defined as the amount of heat released by a unit weight or unit volume of a substance during complete combustion. A Bond calorimeter is used to calculate the calorific value of the liquid fuel. The sample is filled in the sample cup up to its level. Oxygen and power is supplied into the bomb. Due to this, the combustion reaction starts. The rise in temperature is noted from its initial value. Delta E is equal to minus Z into delta T into M divided by W, where Z is equal to heat capacity of calorimeter system, T is equal to raising temperature, M is equal to molecular mass of substance, W is equal to mass of substance taken. The noted values are then applied to the formula to calculate the calorific value of the liquid fuel. Volumetric efficiency. In this video, we will discuss about the volumetric efficiency. Let us see the concept of volumetric efficiency. The ratio of actual mass of air drawn into the engine during a given period of time to the theoretical mass, which should have been drawn in during that same period of the time, based upon the total piston displacement of the engine and the temperature as well as pressure of the surrounding atmosphere. Volumetric efficiency is equal to actual mass divided by theoretical mass. Here, theoretical mass is equal to rho A dot N dot Bx, where rho A is the density of air, Vx is a swept volume, N is the number of intake strokes per minute, is equal to N by 2 for 4-stroke engines, is equal to N for 2-stroke engines. Volumetric efficiency for a naturally aspirated engine is generally about 75%. Example 1. In this example, we find the brake torque and brake power of the engine. Let us see the 3D model of rope brake dynamometer, speedometer. Engine speed is 1000 rpm. Load on the brake is 1000 Newton. Length of the arm is 750 millimeter. Based on the given data to calculate the brake torque and brake power of the engine. Example 2. In this example, we find the brake power developed. Let us see the 3D model of rope brake dynamometer. Dead load on the brake is 210 Newton. spring balance wheels is 30 Newton. Rope wheel diameter is 0.6 meter. Diameter of rope is 0.005 meter. Based on the given data to calculate the brake power developed. Example 3. In this example, we find the indicated power of the 4-stroke diesel engine. Let us see the 3D model of single-cylinder 4-stroke diesel engine. Bore is 0.11 meter. Stroke is 0.12 meter. Piston area is 0.0095 meter square. Indicated mean effective pressure, that is IMEP, PM is equal to 375 kilonewton per meter square. Speed is 60 rpm. Based on the given data to calculate the indicated power at a graph. Example 4. In this example, we find the indicated mean effective power, indicated power of the 4-stroke diesel engine. Let us see the 3D model of 4-stroke diesel engine. Diameter of piston is 100 mm. Area of indicator diagram is 420 mm square. Length of the indicator diagram is 62 mm. Spring number is 1.1 bar per minute. Length of stroke is 150 mm. Engine speed is 450 rpm. Based on the given data to calculate the indicated mean effective pressure and indicated power.
Sandeep. बाहर करो चैनल में.
Example 2. In this example, we find a
ସାଇକେଲଟା ବନ୍ଦ କର, ବନ୍ଦ କର କେମିତି କରିବ? ବନ୍ଦ କେମିତି କରିବ? ବନ୍ଦ ସେଇଟା ଯେଉଁ କ୍ରସ୍ଟା ତ